Hey everyone. As we were thinking about ground zero for zero trust, there was no one in the world who we could have considered, conceived of, thought of better than John Kindervag. And John, thank you so much for joining. For those of you that don't know, John is the creator, the inventor of Zero Trust. And we'll get to that in a little bit. But John is currently Senior Vice President at Onto-It. He was Field CTO at Palo Alto Networks. And before that, VP Principal Analyst at Forrester Research, where I had the good fortune of meeting John first. So John, thank you again for joining us.
It is always good to see you, Kevin.
It is great to see you. Everyone is really interested to think and learn about why, how did you first conceive of, think of the need of zero trust? What was the genesis?
The genesis was installing firewalls at the turn of the century, because if you've ever installed an old school stateful packet filtering firewall, you know that there was a trust model built into the algorithm, right? The adaptive algorithm, which was neither adaptive nor secure, but either way, it had a name. And so what you had to do was you had to take an interface of a firewall. The interface is where traffic flows in and out of, right? Very simple. And you had to assign a trust level. And by default, the internal network was given a trust level of 100, meaning it had the most trust possible in the system. And then the external network was given a trust level of 0. And any other interface, like multiple DMZs, you had to have a trust level that went between 1 and 99, right? And you couldn't have the same trust level on any of those things. So arbitrarily, you're defining these trust levels, which are going to determine policy. So the policy said that if you have traffic coming from the external network, which is completely untrusted, trust level of 0, right, then it needed to have a policy statement, a rule to allow it to go anywhere else in the firewall, because everything else had a higher trust level. And then conversely, if you started at the internal interface, which was the trusted network, you didn't need a rule because you're going from a high trust level to a low trust level. So who cares about rules? And I was installing these things, and first of all, I thought it was pretty arbitrary that you assign this trust level, because when I started looking at the word trust, I realized, hey, nobody even knows what that really means, right? But secondly, I wanted to put outbound rules, and no one would allow me. But we want to make sure that traffic isn't, no one's stealing our stuff. Oh, that would never happen. Well, it happens all the time. And it's this broken trust model that when I finally got to Forrester, I was given the freedom to take head on. And people still don't get that. They will say today, oh, the goal of zero trust is to make the system trusted. No. How much trust should there be in a system called zero trust? 0. Every interface should have, in that example, the same trust level, 0, so that you have to make a rule that determines what traffic is going to go from what interface to another to access some resource on the backside of that interface. It's a very simple thing, right? But people are in love with this word trust. It's amazing how hard it's been for people to give it up.
I think you probably got to this a bit. I mean, why? I mean, back in the day, so 2011, 2012, why did zero trust start to catch on? Why did it succeed where others had failed?
Because others were failing, and people who were cutting edge said, what's the cutting edge thing? And they would reach out to Forrester, or they would hear about it and they would have me come in. So I remember kind of the first big thing I ever worked on. The CEO of a major company had a visit from the FBI, and the FBI said, hey, how come all of your intellectual property is over on this server that we found in this former communist bloc country? And he said, that's not a problem. That's not possible. And he calls the CISO and down the chain to the CIO, everybody. FBI says that all our data has been stolen. And they're like, it's not possible. The network's up and running. Everything is fine, right? And here's this incontrovertible evidence that the FBI, has these documents that are top secret and shouldn't, how do they have them in a folder, right? They've printed them out and, pass them across. And so the CEO just went nuts and he was like, find me the most cutting edge thing in cybersecurity. And somehow through this circuitous route, it ended up coming to me, and I ended up working with this company and doing big workshops, and there was always little people who were intrigued by it, and it was just something that resonated to a certain group of people, that they
So if
hated
you
the
could,
word trust, they hated the way we've been doing things, and they wanted to do it differently.
so what was the 30-second description definition you gave to the CEO that made the light bulbs go off?
That this trust model where we assign trust, a human emotion, to an interface and a packet and data,
Hmm.
is the fundamental problem. That everything, every data breach is a result of taking advantage of the trust model, right?
Right,
So
right.
it made sense. It was much easier for me to describe it to a senior strategic leader, a CEO, a member of a board of directors, a general, an admiral, and I would always get pushback from the technology people. No, this is how vendor X has always told us it has to be done. So there's no way to deviate from it in our world because that's who we get our certifications from.
Right. So it sounds a lot like, along the way, the story of machine identity, which is, there are two actors on a network, on the internet, the cloud. There are people and their machines, and some use usernames, passwords. The humans biometrics, others machines, APIs, cloud instances, Kubernetes clusters use different identities. It sounds like, I mean, that opportunity to share a story that connects, I think was really powerful behind zero trust.
That relates to machine identity and the stuff we're talking about here is that there are no people on a network. It was the anthropomorphization
Mm,
of the network that's killing us. The idea that John is on the network, that Kevin is on the network. Well, we're not.
right.
I think you're in London, if I remember right. I'm still in Dallas in my same chair the last time we talked. And I haven't been shrunken down into a subatomic particle where I've been transferred via my wireless network to the public internet to this particular server, so that you can see it on the other side of the world. That hasn't happened to us, right? It rarely happens in the movies, Kevin. It happens in
Right, right.
Tron,
I have a
Lawnmower
machine,
Man.
of course. Yes, you're right. I have a machine that I have authenticated to. And then that
Right.
machine is then doing work on my behalf. If we were on a Zoom call here, yeah, I've authenticated to Zoom, and then Zoom as an application, essentially a machine, is talking to the cloud, another machine, which that
Right.
cloud talks to another machine, which ultimately gets back to John, and the bits that
But
displayed on your,
Kevin or
yeah.
John is just an assertion on the system, right? And so it's always asserted. Now, when you get into something like machine identity, because I was talking about identity, device identity, and data identity years ago, and people who were in the
Long time.
identity business used to push back on that and go, "No, only people can have identity." Well, not true in the digital world because there's no people here, right? And I've always said people are not packets. That was one of the kind of the things
Mm.
that I said. I was going to wear a shirt today that said people are not packets, that somebody had sent me. Zero trust networks, people are not packets. And then I had it on. I realized they misspelled the word network. And I thought, okay, I can't wear it. But it's that idea, right? Come on, folks. It's a packet. Authenticate every packet, know what it's doing, know whether it's supposed to be doing it, know whether that packet is dragging along in its payload some threat stuff, and control that, right?
Perfect. And obviously, we're here working on that problem on machine identity management. So, John, you shared with me something really interesting, which, thinking about a bit of history. So, we're talking here a bit about England and English people. So, Rudyard Kipling, you
Mm-hmm.
told me that he had something a long time ago to help us understand zero trust. What is that?
He wrote a poem in a collection called Just So Stories, and it goes like this: I keep 6 honest serving men. They taught me all I knew. Their names were what and why and when and how and where and who. And he resurrected the idea of who, what, when, where, why, and how, which he kind of had gotten from Aristotle. And this actually had a lot of usefulness in the business world. Um,
Mm.
Sometime in the 40s and 50s, people wanted to ask those questions. Who's doing what? Why are they doing it? How are we doing it? Right. But in cybersecurity, we never asked those questions. And what I found was this construct, who, what, when, where, why, and how, exists in every culture, every language around the world. So I could create a policy statement using that everybody could understand. They could read it, they could write it, they could audit it. So who has access uh, to who is going to access a particular resource, and that who can be a person, an assertion of a person or a device or a piece of data. It doesn't matter. It's a packet, right? But who should have access via what application? Where is that located? The thing we're trying to protect, the data or the asset or the service or whatever they're connecting to.
Right.
We can put time limitations on it. When should that happen? A lot of times we just open up rules and people get hacked in the middle of the night because no one's looking at what's going on. And then we can say, why are we doing that? You can add any kind of metadata to a packet. A packet is pretty amazing thing that we underutilize. So put some metadata in there. We do that in our managed
Hmm.
service
Hmm.
to contextualize the packet. And then finally, how are we doing it? What is the criteria we're going to ascribe to that flow? So we're going to say, oh, well, this has sensitive data in it, so we're going to run it through a DLP engine. Or we're, this particular asset is subject to a particular type of attack, so we're going to run it through a DPI or IPS type of
Yep.
functionality, whatever those criteria are. And if all those things are true, then we're going to allow it. And so zero trust is a set of granular allow rules because all bad things happen inside of an allow rule. So we want that allow rule to be small and
So
as
those,
granular and as
yeah, yeah.
specific as possible.
So those simple questions, I think, in machine identity, we can apply a lot of the same framework or ideas we thought about humans. So the who, but of course, who really anyway is always really a machine. So we can apply that. I think those questions as we think about what are machines doing, whether that's an app calling an API or a Kubernetes cluster, an app there talking, calling to a serverless function, or you fill in the blank. That's really great insight. So one last question then, John. So we're technologists here. We love to think about products. Next version. Question I get asked, you probably get asked, is there a future for zero trust? Like, is there a version X.1? Is there a future for zero trust?
Well, of course, there's a future. I mean, we're just in the beginnings of the present, right? Because we've just had the presidential executive order issued in 2021 that changed the incentive structure and said it's okay to talk about it because it used to be zero trust was like Fight Club. The first rule is you don't talk about it. So a lot of the things that were going on were kind of being done in secret. So now the president has changed that and said talk about it. So that's a good thing. Secondly, zero trust was purposely decoupled the strategic elements from the tactical elements because I knew the technical part, the technology, the operational things, all that stuff will get better over time. But the strategy will generally remain unchanged. There'll be nuances or some more things we'll learn, but the strategy has really remained unchanged since the first paper in 2010, No More Chewy Centers. The strategy about eliminating trust. That won't change. What will change is the technology will get better and better and will be easier and easier to deploy and it'll become more and more automated and it'll just become de rigueur. If you're not doing it, what are you doing if you're not doing that?
Right.
Because you're doing it wrong.
So the future is bright, but there's not a future version, iteration that's coming as we oftentimes think
Well, I mean,
about.
I will never say never because I'm doing research into the post quantum world. But so
Mm.
far, the strategy seems like it's going to work well in the post quantum world because that's the big disruption. Now, technologically, we'll need things, and you're in key and certificate management. We're going to need what people are all buzzed about: post quantum encryption and post quantum attack methodology, post quantum attack
Mhm.
protection, and all that kind of stuff. But strategically, there'll still be something that we need to protect, right? And we'll need controls to protect it, and we'll need policy to
Yes.
enforce the protection and define it, and we'll need to monitor that to make sure it's happening in the right way. And so those things won't change.
So we'll always need to have the who, what, when, where, why, and we're always going to be talking about machines, which machine identity is going to be really critical, important to that, and important to a zero trust strategy. So, John, thank you for joining, and of course, always look for John on LinkedIn, and he's oftentimes traveling around the world. So, John, great to see you, and I'm looking forward to that barbecue next time. Thanks, John.
You bet. Thank you guys.
See
Thanks
ya.
for having me. Appreciate it. Stay safe.